All right, so have you ever wondered if you could run your air conditioner directly off your solar panels? I mean, especially during a power outage on a hot day. We're talking no grid, no expensive batteries, just pure, glorious sunshine. Well, today, we're going to dig in and find out if that's actually possible. So, yeah, that's the big question, right? Can you really power one of the most energy hungry appliances you own, that air conditioner, straight from the sun? Is it a dream or reality? I mean, just picture it for a second. It's a blazing hot afternoon, the grid goes down, but you've got solar panels up on the roof. The dream, the absolute goal, is to use that sunshine to get some cool air flowing inside, without needing a massive, super expensive battery bank. But is that dream even realistic? Okay, so let's really investigate this. It's a super popular idea in the DIY solar world, but is it a practical solution or is it just, a fun thought experiment? So, what we're actually looking at today is a real world experiment, and the goal was super clear: power a standard 10,000 BTU window AC unit using only the energy coming from the sun right then and there, in real time. Now, to really get why this is such a challenge, we have to meet the main villain of our story, and that is the AC's compressor and its incredible thirst for power. And here's the thing that might surprise you. The amount of power that AC needs to just run once it's going, that's actually pretty manageable. The real problem, the massive, massive hurdle, is just getting the thing to start in the first place. And this brings us to a really key concept called surge power. Think about it like this. It's like that huge, massive shove you need to get a stalled car moving, right? Once it's rolling, it's pretty easy to keep pushing. But that initial effort, it's immense. Well, an AC compressor is exactly the same. It needs this huge jolt of electricity to go from a dead stop to full speed. And wow, this chart just perfectly shows you the difference. Take a look. To run, the AC is chugging along at about 1,000 watts. Totally reasonable. But to start, it can demand more than 2.5 times that. We're talking over 2,500 watts. And that massive spike is what our batteryless solar system has to handle all by itself. Okay, so now that we know the challenge, let's get to the fun part, the actual experiment, and see how they tried to tackle this massive power surge in the real world. So the setup was pretty straightforward. They had a standard window AC unit, a bunch of 305-watt solar panels, and then the real key to the whole puzzle, a 6-kilowatt inverter. And this inverter had a special islanding feature. Now that's a super important function. It basically lets the system safely create its own little mini-grid, totally separate from the main power lines, powered only by the sun. And the whole experiment was classic trial and error. They started with what they thought would be enough panels. Spoiler alert, it wasn't. They hit a wall, so they beefed up the solar array, and then they tried again. So, let's walk through exactly how it went down. Okay, so for the first attempt, they hooked up 8 solar panels. On paper, that gives you a capacity of about 2.4 kilowatts. I mean, that's a pretty respectable amount of power, right? And here's what happened. The AC unit's fan, it turned on, no problem at all. It was only drawing a tiny 156 watts. But the moment that big compressor tried to kick in and start the real cooling, nope, the whole system failed. It just could not deliver that massive surge we were just talking about. So back to the drawing board. They added more panels to the array. This pushed the actual power being generated in the sunshine at that moment up to 2.5 kilowatts. So the total rated capacity of all the panels was now closer to 3 kilowatts. So would this be enough? And success. It worked! With that extra solar power on tap, the inverter could finally handle that huge initial demand. The compressor roared to life, and the AC started blowing cold air, powered by nothing but the sun. How cool is that? And here's the real kicker. Once it was up and running, the AC unit just settled right down and was only sipping a comfortable 1,060 watts. This totally confirms the whole theory, right? You need this massive amount of power on standby just for that one split second of startup. All right, so let's get to the verdict. What does all this mean? The short answer is yes, it is absolutely possible. But, and this is a really big but, we need to talk about the catch. And here's the catch. While you can do it, it's actually really, really inefficient. Think about it. The experiment proved that you need to have about 3 kilowatts worth of solar panels installed just to reliably start and run a 1 kilowatt appliance. That's a 3-to-1 ratio. And this chart, this just shows that inefficiency perfectly. Look at that.
2/3, 67%, of your entire solar array's capacity is basically just sitting there doing nothing. It's surge overhead. It does its one job for a single second at startup, and then all that extra power potential is just wasted for the rest of the time the AC is running.
So if just throwing a ton of extra panels at the problem isn't the best answer, what is? I mean, there's gotta be a smarter way to do this, right? Well, let's look at some better ways to get the same result.
And the answer really lies in the type of air conditioner you use. See, unlike a standard AC that's just on or off and demands all its power at once, an inverter drive unit, like you find in modern mini splits, is way smarter. It ramps up slowly, nice and gradually, completely voiding that massive power surge. And that makes it a perfect match for a batteryless solar setup.
So what are the big takeaways here? What should you remember? Okay, number one, if you want to do battery-free cooling, go for an inverter drive AC. It's just way more efficient. Number two, you gotta remember this is a daytime-only solution. No sun, no power. Simple as that. And finally, this kind of direct from solar setup is fantastic for other critical loads during a power cut, like keeping your fridge and your freezer running all day long.
And all of this leaves us with a really fascinating question to think about, right? As our appliances get smarter and more efficient, could this whole idea of direct solar cooling become the new standard for hot, sunny days? I mean, it kind of proves that sometimes the best solution isn't about making more power, but about using the power we have much more wisely. Is battery-free cooling the future for sunny days? It just might be.